Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering where study elaborates decoding the earth to build a better world. Today we will go through the core concepts related to the remote sensing, satellite classification and case studies. Here, a platform in space which is designed to measure and record electromagnetic energy which is reflected or emitted by the Earth's surface and the atmosphere, that is nothing but a remote sensing. Here, this satellite is a space-based platform that records EMR or electromagnetic energy which is reflected or emitted on the Earth's surface or from the Earth's surface and the atmosphere. It provides a view allowing engineers to observe that large regions that are difficult to survey from the ground. Here the sensing process involves interaction among the sun, earth surface, atmosphere and satellite sensor to generate useful spatial informations. With reference to civil engineering point of view, the satellite data supports land use mapping, infrastructural planning, watershed management and environmental monitoring. Here the process from the source of light, that is the sun, to the earth's surface with reference to its geodetic curvature. In between them the atmosphere and the sensor are working together. Here the sensor which is revolving with reference to its orbit, the data or the region which is exactly below to that sensor on the earth's surface, that will be the nadir point, and the area which is traced or path which is traced by that sensor, that is AB width, which is nothing but a swath. The system anatomy point of view, we can see the bus versus the sensor. Now the bus means the vehicle and the mission system, that is the payload. Here the solar array, high gain antenna, thruster blocks, these are all the components of that bus or the vehicle which is useful to provide power, propulsion and telemetry. Whereas the mission system, that is the payload, where that is the instrument that dictates the data by using the sensors passively or actively. That passive sensors naturally energy using sunlight and collect the data, where active sensors, they are based on the radar system which supplies own energy. So the key concept for that system anatomy is that the orbit determines where we look and the sensor determines what we see. Means the satellite bus provide power, propulsion, attitude control, communication and overall system support. That payload or sensor is the mission component responsible for collecting earth observation data, whereas these sensors are the passively or actively working on the basis of sunlight and radar system simultaneously. The civil engineers, they are dependent on that sensor data for terrain analysis, urban planning, transportation studies and resource assessment and management. Now the classification of that satellites based on some applications like earth resources, meteorology, microwave or radar and many more. Here the remote sensing satellites are classified according to their applications, just like meteorological, environmental, microwave, radar, earth resources. Earth resource satellite like Landsat and IRS are primarily used for mapping resources, naturally or human made features. Meteorological satellites monitor weather systems, while radar satellites collect information of cloud cover. Different satellite categories which are providing the data on the basis of specialized condition for civil engineering purposes like planning, execution, monitoring and hazard management. Here the satellites are the geostationary satellites which are of the meteorological purposes. GPS and navigation satellites, they are the MEOs and LEOs, low earth orbit, medium earth orbit and geosynchronous or geostationary satellites. Likewise the whole orbits are divided of that classification point of view. Next one will be the sun synchronous polar orbits. Here the sun synchronous satellite operate at altitudes of approximately 600 to 900 km with inclinations close to 98° to 99°. They cross the equator at the same local solar time during each pass or each movement, ensuring consistent illumination conditions. That consistency which improves the image comparison mosaicing and long-term monitoring advantages. Here, with reference to civil engineering and applications point of view, that includes the land use mapping, infrastructure monitoring and watershed management using uniform imagery, which is collected by using that sun synchronous polar orbits with the time of day, that is 9:45 am, where the whole orbits are intersecting at the point. One will be the geostationary orbits. Geostationary satellite orbits are approximately 36,000 km and complete one revolution in 24 hours. For means that one revolution 24 hours, that is one day. They remain fixed relative to a specific location on the earth, providing continuous observation with reference to their major applications, which include weather forecasting, cloud tracking and communication services. In civil engineering point of view, geostationary data that supports flood forecasting, storm monitoring and disaster preparedness with reference to that geostationary orbits. Next, that is a comparison of low earth orbit, medium earth orbit and geostationary orbit on the basis of altitude, period and usage or application. So low earth orbit satellite provide high spatial resolution and they are widely used for earth resource mapping basically. Medium earth orbits, they are the satellites are commonly used for navigation system just as GPS and GNSS. Geostationary orbit satellites provide continuous coverage but generally have lower spatial resolution. With reference to civil engineering point of view, we can choose the satellite data which is based on some project requirements. Here the period of low earth orbit is 90 to 100 minutes. For medium earth orbit it is of 12 hours and for geostationary it is for 24 hours. With reference to that altitude, they are also 2000, 20,200 and 36,000 kilometers simultaneously, that is LEO, MEO and GEO. Case study point of view, we can see that the Landsat series where the standard of earth resources. So what are the technical specifications? That is orbit, sun synchronous near to the polar, altitude is 705 km with the inclination of 98.2 degrees, where equatorial crossing 9:45 am, where revisit cycle is of 16 days and sensors used are MSS, TM and OLI. Here the Landsat program is one of the most important earth observation mission for resource and environmental monitoring. Landsat operates in sun synchronous orbit with approximately 705 km altitude. The civil engineering point of view, we can use it for the urban growth studies, land use mapping, planning, watershed management assessment and environmental monitoring purposes with the components of multispectral scanner MSS, thematic mapper TM and that high gain antenna with solar array, that is S band antenna and X band antenna at the same. Next case study is of IRS series, that is ISRO based Indian remote sensing program, where indigenous program for national development based on agricultural, water and disaster point of view. Indian remote sensing program was developed with the mission such as IRS-1A, IRS-1B, OceanSat and ResourceSat that provide valuable data for agricultural, water resources and disaster management point of view. LISS, that is linear imaging self-scanning sensors, offer spatial resolutions ranging from 23.5 meter to 5.8 meter for detailed mapping purposes. Here the civil engineers use that IRS, that is Indian remote sensing data for infrastructural planning, groundwater studies and land use mapping purposes. Then meteorological satellites. Meteorological satellites are the polar orbiting satellites or geostationary satellites, NOAA or GIS, where sensors are AVHRR and VISSR. Likewise, swath area is given, resolution and usage. So the satellite operate in polar orbits and provide wide area environmental observations. With the GES satellites or geostationary satellites that operate in geostationary orbit, where NO and AA, that are the polar orbits or polar satellites basically, that geostationary orbit that provide frequent weather updates over the same region. These satellites monitor cloud cover, sea surface temperature, storms, and atmospheric conditions, with the civil engineering applications that include flood forecasting, weather risk assessment, and disaster management planning. Now, the microwave or radar satellites, that are the active sensing capabilities, where the advantage is that they are transmitting their own energy and penetrates clouds, fog, and darkness with the effective output. Radar satellites are active sensors that transmit their own microwave energy and that receive reflected signals. They can acquire data during day, night, cloudy conditions, and adverse weather situations also. For example, that includes Seasat, Radarsat, RISAT, which provide reliable all-weather observations. So with reference to radar pulse and backscattering effect, they are collecting the data. So civil engineering application point of view, it is critical for flood mapping, landslide monitoring, and disaster responses. Moving towards the advantages and limitations point of view. So what are the advantages? They are listed below on the basis of Synoptic view, repetitive coverage, and digital image format. Whereas the disadvantages or nothing but limitations point of view, we are seeing the resolution point of view, atmospheric condition, and cost or finance required. Limitations which include lower resolution compared to aerial surveys and atmospheric interference with optical sensors that enables efficient monitoring of environmental changes, urban growth, and infrastructural development. The satellite imagery provides large area coverage, repetitive observations, and direct interaction with GIS platforms. Under, with reference to the understanding of advantages and limitations, or we can say that the constraints, that helps to civil engineers which select appropriate data sets for specific project and data required. The summary and the civil engineering relevance, where the summary satellites are chosen based on the trade-off between resolution, that is a special type of resolution, and the revisit time, that is a temporal resolution. Means the satellite selection involves balancing spatial resolution and temporal revisit capability according to project needs. Remote sensing supports water resource management through reservoir monitoring, floodplain mapping, and watershed analysis. The GIS and satellite data which assist in town planning department with reference to urban sprawl and land use changes. GIS and satellite data assist land use change detection also. At the end, the rapid satellite observations play a crucial role in disaster assessment management, which includes flood, earthquake, and other natural disasters, where the rapid revisit time is utilized to take the more information and reliable information. Stay tuned, guys. Happy learning.